Hello, everyone. I am happy to introduce today the keynote speaker of the 14th Hellenic Congress of Hypnology, which is in English the 14th Greek Congress of Sleep Medicine. And at this point, I'm located at Penn State in Hershey, Pennsylvania. And I'm really happy to introduce to all of you, good friends and colleagues, Dr. Erna Arnarddottir. She's an associate professor of the Department of Engineering, Department of Computer Science at Reykjavik University, Iceland. She's also the director of the Reykjavik University Sleep Institute. She has over 20 years of experience with the field of clinical and scientific sleep research, and she has co-authored more than 90 highly cited peer-reviewed papers. She's currently the president of the European Sleep Research Society, and she is also the principal investigator of a grant from the European Union Horizon 2020 Research and Innovation Program. The project that I'm sure she's going to give us some input today, it's called Sleep Revolution. It's an interdisciplinary international research and development project, and the goal is to introduce an approach based on machine learning to improve how we diagnose sleep apnea and how we can treat better than our current methods. On a personal level, I have met several times. Erna, 2002, it was my first time in Iceland. Along with Dr. Gislason, we here at Penn State and Dr. Bixler had always very good feelings about the research done by our colleagues in Iceland. I have met her since then several times in Germany, here in the United States. She's a very nice person, very friendly, very good in her research. But also I remember, Erna, something that you told me once. It was approaching Christmas. They said, Erna, are you going to stay in the United States to do Christmas, or are you going back to Iceland? I said, hey, Dr. Gonzas, Christmas outside of Iceland is not Christmas. So my good Greek friends and colleagues, though that you plan to spend Christmas outside of Greece, please consider Iceland as a place to live, the true Christmas spirit. After this introduction, Erna,
Thank you. Thank you very much, Alex. I can't believe you remember that from 2007, by the way. So it's been a long time that we have I've been following your research. So thank you very much for inviting me here today. It is my pleasure to be here. Even though I was laughing with Alex about this while we were waiting for this to start, that you Greeks are a bit crazy to start your conference on a Friday evening, and it's even later for you than me. But I'm very happy to be here today. I just wanted to show my conflict of interest, as I do work with a number of companies, because we believe that the only way to move the field forward is to work with the companies, but none of them have a direct influence on any of the work that we are doing, of course. So as Dr. Vagonsos just said, we have this Horizon 2020 grant. This was a 15 million euro grant that we received from the EU for a 4-year project that will end in mid-year 2025. And in this project, we actually have 39 partners. So we lead it at Reykjavik University, and it's really my honor to be the principal investigator of this project. So we have a number of universities and hospitals, and this includes the very important ESADA network, the European Sleep Apnea Database. And you should recognize quite well at least 4 of the logos here, because we have 4 Greek colleagues that are working within our project. So I'm actually thinking I need to do a sabbatical in Greece now and travel between all of these wonderful places, but we'll see what happens. The ESADA network has, of course, been working together already for many years, and they have a lot of data collection that we are using in the Sleep Revolution that has been done retrospectively. We're getting all of the raw sleep studies, and now we're doing these prospective studies where we are collecting data that I will tell you about a bit later. We also have industry partners. We have expert societies involved, such as the European Sleep Research Society, and we believe this is really important as well, so that for that we can really have the key opinion leaders in Europe as a part of our research work, and that we can make clinical guidelines and very influential papers coming from this project. This also includes then the ANSS, and then the Greek Society is in fact in a way partner in the society or in this project. It's also supported by the ERS and some additional companies. So you can see here for Greece, we have 4 partners, but we also importantly have partners all over Europe. So both from north to south and east to west. And it is of course very important when we're validating new technology and we're validating algorithms that they are not just made for example, for Icelanders. And we are really testing now in them. We have 15 languages for our development, and a lot of different profiles of people who are then testing our devices. To start with, I wanted to talk about one of the major aims of the grant is to move from the typical single night sleep recording, which is then the in-lab PSG as the gold standard, or simplified home sleep apnea testing, where we don't measure sleep per se, but really only breathing during the night. And this is not, for example, as strong for females and people with milder disease than when you have when you actually do measure the sleep itself. So you may lose out on some significant disease of sleep apnea when you just have the simplified recordings. And with the in-lab ones, there's so much cost and such high waiting lists in many of our hospitals that we are not able to reach all of the patients we would like to reach. So in the Sleep Revolution, we are working with multi-night sleep recordings for 3 nights. It's self-applied, and people set it up themselves at home and in their own language. And we're also working with long-term monitoring, both using wearables and an app that we have been developing in this project. I will tell you more about that. So the big question here is really, can we bring advanced sleep diagnostics from the hospital into the patient's home? We know we can do it now for the simplified studies, but can we really bring a PSG into the home and that people put it on themselves? And for this to work, we have to see that whatever device we are using, that the quality of the signals and the scoring is comparable to the gold standard polysonography setup. The self-applied quality of the study needs to be good. And the experience of the patient also has to be good. So they're not feeling very stressed or having some issues with the setup. Finally, and not least, not any less important than the other parts, is we have to validate it for the relevant patient group. So for example, now I'm going to show you results from a pilot study that was done in Iceland, and this was on a mixed group of subjects, so not, for example, just OSA patients. So now we are validating it in people with suspected sleep apnea across all of these European countries. And this is very important. And this doesn't mean we can move it to an insomnia group, for example, or a PLM group. We would then want to validate it there as well. We started off by doing a double setup validation. This is actually one of our PhD students, and he actually has on 2 devices from Nox Medical, which are then partners in the grant. And you can see here on his forehead is this more novel setup of the EEG. So there's actually, in the new setup, there's no EMG on the top of the head or on the back of the head, because it's very hard for people, of course, to put something in their hair. There's also no EMG on the chin in this novel setup. We only have EMG from the forehead. So this is something that we need to make sure we can still score the studies without losing too much clinical information. You can actually also see that he has on 2 different smartwatches, which we were testing in the same study. So we put this on 200 adults. We've also put it on over 100 children. And we were looking at the technical feasibility and that the signals look similar or the same so that they are scoreable. And what we found in these studies is that if you look at the PSG, this is the strength of the signal across different hertz. So here, for example, you have the peak around 12 hertz, where you have the spindles. And you can see the green and blue, this is the signal envelope, or the strength of the signal for a PSG, while the orange and the purple, this is what we have in the self-applied study. So overall, the signal is, the strength of the signal is a bit smaller, and that's because when you put it on the forehead, you are going through a smaller part of the brain. So you have more space in between when you have it on the behind the ear. But it doesn't change the characteristic of the signal itself. So it follows the same lines, you're picking up the same changes, but what it does mean is when you are scoring deep sleep or S3, you have to change the amplitude cutoff because the delta waves will then, you need to score them at 45 microvolts instead of 75. Similarly, if you start changing the filtering, because there's a little bit different baseline noise in this self-applied setup, then you may actually need to change the amplitude cutoff to 40 microvolts. So this was one important component. We are now actually, we are running the analysis for having it blindly scored as a self-applied study or a PSG. And we have done that for the children. It came out quite well, but we need to finalize it for the adults as well. The next one was to look at the self-applied sleep study. And here we did a pilot study in Iceland. Here you can see just the setup of the self-applied study and this video for 8.5 minutes that has now been then put into 15 languages, including Icelandic and Greek, of course. And we are validating this now in 24 of the Asara centers, which then have a total of 1,000 patients who are come in for sleep apnea screening. So these are real life patients who are then either randomized to having the self-applied study first or the typical in-lab study first. And then we see the difference in clinical decision-making based on these two. And we will see how many people are able to use this successfully. We just published this paper. I don't know if I can move this here. Sorry, yep, I can move it a bit. We looked at then the feasibility and the usability of having 3 consecutive nights done in this way with the self-applied home polysomnography, just published in the Journal of Sleep Research. We had 78 participants in Iceland. Out of those, 47 or 60% had valid nights that could be scored and used for all 3 nights. Further, 27% had 2 nights and 13% had 1 night. So everybody had at least 1 successful night, and most people were able to do 2 or 3. So if you think about night-to-night variability and OSA severity and in other indices, as well as the potential adaptation night effect, you are able to get a more in-depth analysis this way than by just having 1 night in the laboratory. And we could see this in the results that the sleep efficiency actually increases, the objective sleep efficiency from the PSG increases from night 1 to night 3. And there is significant night-to-night variability in the mild OSA group. So depending on the night, they could either be decided that they have no OSA, mild OSA, or moderate OSA. And then the question is, which night do you capture these people on? If you just do 1 night, if you give them treatment or not. We also saw, if we asked people how long it took them to put on the device in the evening. And from night 1 to night 3, you can see there's much more people that are then doing it within 15 minutes, and almost everybody is able to do it in 30 minutes or less. So the experience was actually quite good. We've also been doing a lot of work with the consumer sleep technology. We don't have as many of those papers already submitted, but we have been working mainly on guidelines for how to do protocols for developing and validating all of this new technology. And we have been using them in all of our studies. For the analysis, so it's one thing to make the, if you can do the studies themselves in a less costly way. But we are also then moving into the home and having 3 nights for at least some of the patients. I don't think we will need it for all patients in the future, but there will be a group of patients that have more variable prototypes or profiles, and they may need 2 or 3 nights. We just chose 3 nights because it's the maximum of the battery life. So it's not necessarily any gold number to have 3. But the other factor for PSG is the manual scoring, which is also very time consuming and expensive. And this is then typically 2 to 3 hours per night per patient if you really follow the AASM rules for scoring. And we really need to move this into more machine learning based scoring with more instant results. And what we're looking at here is not just having artificial intelligence where machines replace human processes and make decisions for us, but rather augmented intelligence where the machines are aiding our human processes and they're suggesting decisions for us. But there's always a human in charge, which makes the final decision. And to show you an example of how we are thinking this, is that we have here this recently accepted paper in JSR. I don't think it's formally available yet, but it should be in the next few weeks. And here we are looking at automatic sleep staging, and we're comparing it to 10 different scorers. So we actually, if you look at this picture, we had 10 expert sleep technologists or clinical experts who are used to scoring PSG. They all scored the same 50 PSGs and then also 50 self-applied studies. And on average, people agree. If you take two people with who are sleep experts, the agreement is like 80% throughout the night. But when you look at all 10, it's actually only half of the epochs of the whole night that everybody agrees is a specific sleep stage. And this is, of course, an issue when we then want to have automatic analysis, and we need to trust them to tell us which sleep stage it is. But if humans can agree, what is the automatic analysis supposed to do with that? So here we're looking at, if you, for example, see here in the middle, I hope you see my arrow, there is N3, and everybody is agreeing that this is N3. But then when you go a little bit further, you start having some people saying it's still N3, others say it's sleep stage 2, and it's quite different when people start moving into REM, for example, here. But there are here areas that we call gray areas where there's a lot of disagreement between people, and it's quite unclear what is the true sleep stage. While here, at least the majority of people are agreeing. And we tested in our model for automatic sleep analysis, we tested which areas the model can predict with certainty and where the model has uncertainty. So they always give you a sleep stage that they believe is the correct one, but we are visualizing here that these are the sleep stages that the model is not as certain about. And you can see it's mostly the same areas as we have for the manual scoring. It's not identical, but generally it's the same areas. And we are then using this now for the scoring in this ASADA study with 1,000 patients. And we are visualizing these gray areas from the model to the sleep technologists and sleep experts so that they don't have to spend their time, for example, looking at this area here where almost everybody agrees this is sleep stage 3, but where there may be issues, we spend our time there. So basically, this is what we're doing in this ASADA study. We do the automatic sleep analysis. There's a predicted hypnogram. Our sleep technologists and experts manually review the gray areas to get a final hypnogram. But we can also use this manual review in so-called active learning to improve the automatic analysis. So that by iterating this circle again and again, we get more and more better automatic analysis. Finally, for the diagnosis, we have been relying on quite simple indices like the AHI and the Epworth Sleepiness Score, the ESS, to decide if someone has sleep apnea or not. And of course, there's much more happening behind the scenes than just looking at the AHI and the Epworth Sleepiness Scale. But at the moment, none of these are clinically validated, and they are not included in our guidelines for how to decide if someone needs treatment or not. So we want to really push this into more complex correlations and phenotypes of sleep disordered breathing and obstructive sleep apnea, and also that the patient can see their own data and they can see if they are, for example, improving in sleepiness over time when they go on CPAP treatment. And then they can be more participatory medicine for them. Same for the follow-up. At the moment, I mean, it's wonderful that these CPAP machines have the ability to see if there's a reduction in AHI, if people are using the device, and if there's a leak. But at the moment, we don't really know if people's sleepiness is decreasing, if people are claustrophobic wearing their CPAP, or if there's any other issues. Because in most hospitals, we don't have the resources to do this, and we really need a digital follow-up for the future to be able to do this properly. So in all of this, we are working with the so-called co-design, where we work with the patients from the get-go. And when we make any tools, any visualization of their own data, and we also work with the healthcare professionals to make sure that whatever we are designing is actually thoughtful and beneficial for the particular group you're designing it for. And this was not done so much in the past. For example, when we were making all of these medical record filings and software for that, I think many of them would have been much better if the healthcare professionals had been included in the design process and not at the later stage. We use this co-design method, for example, to create our app, the Sleep Revolution app. In this one, we have a morning and evening sleep diary, where we ask people both about how their day was and how their sleep was. This is based on the consensus sleep diary, which was developed for paper, but here is then in an electronic form, and people get notifications to remind them to answer, and they can choose the time they want to be notified. They can also reduce the burden of these questions by, for example, if they never drink alcohols, you can push this down, so you never get a question on alcohol. Same for caffeine and sleep medication. And we are actually asking people to answer daily for 12 weeks in all of our prospective trials in the Sleep Revolution. We did a pilot study where there was no end goal, no treatment, and we asked people to do this for 12 weeks. And it's actually quite amazing how many people are willing to answer for up to 12 weeks. You see there's quite a bit of drop here from day 80, but this is mainly because people were coming in and returning the wearable they also had and finishing their study participation. So it's not so that everybody was exactly there for 90 days. But you are getting up to 63% of people still answering the morning sleep diary, a little bit lower for the evening, without even getting any treatment or change in their life. So we really hope this will be replicated in the prospective ESADA study and see how people are engaging with our app. In the app, we not only have the subjective assessment, we also have something we call brain games. And this is basically cognitive tasks or cognitive testing. The reaction game, for example, is a 3-minute version of the psychomotor vigilance test. And then we are asking people to do these weekly. And we can see now, for example, for those people who go on CPAP treatment in the ESADA study, we can see how their PVT, how their memory, etc., changes throughout the treatment course. We've also generated a new questionnaire. It's called the European Sleep Questionnaire. This is led by Dirk Parvinacci and his team at Ghent University in Belgium. And we decided to generate this because we feel at the moment there's no overall questionnaire that really gets people's sleep profile, because you need a lot of different components to get the overall profile of the person, to understand what are their sleep disorder issues and other sleep health issues, both for nocturnal sleep and for daytime functioning. So we have put this also in we put this in our digital platform. It's not in the app, but it's answered online. And then people get visualization from their results, different visualization for the healthcare providers and then for the patients or participants. And you can see, for example, something like a spider plot where you can see before treatment how people were doing on different dimensions, and then after treatment if there's a decrease. So really at a glance, you can see if the treatment is working or not for the patients. We, aside from the ESADA study, which uses the traditional CPAP, we also have 2 other prospective randomized controlled trials, one of which was a lifestyle study where we asked people who are they are sedentary, so they're not exercising regularly. They're overweight to obese with sleep apnea, and they are willing to start an exercise or lifestyle intervention. So we started with 192 people who were randomized to intervention group. One group was a so-called exercise group, which then came 3 times a week to our university sports science lab and met with a trainer. And we designed a lifestyle or exercise program with our sports scientists in our group. One group had a lifestyle app. So they were trying to motivate them using an app to enhance their lifestyle, eat healthier, exercise more, etc. And a control group did all of the measurements of the self-applied sleep study, the wearable, and the app, but they were not asked to change anything. In the end, there was some dropout, of course, as expected, but in the end, we had data for 32 up to 40 people in each group, which is actually larger than any other exercise group so far, exercise study so far in the field of sleep apnea. So this is just a submitted paper at the moment, but I wanted to show you some key results. Interestingly, we see that the AHI decreases by 20% in the exercise group, and there we're really focusing on increasing muscle mass, not necessarily of losing weight. And we can see this also that in all variables we include to measure skeletal muscle mass and endurance, improve physical fitness, etc. This is all happening in the exercise group, while the app group actually they actually reduce their weight significantly, which the exercise group does not. but they do not change their AHI at all. So I think the important message here is that if we want people to reduce their AHI or OSA severity, it's not enough just to say, go have a lifestyle change, eat less, exercise more. We need to design the exercise program very well. So we really are targeting the muscles and physical fitness that we need to affect with our programs. The last randomized controlled trial we have is with myofunctional therapy. We're doing this one in Norway and in Estonia, where we have experts in this type of treatment, and they developed this myofunctional exercises, which are actually done through the app. This is one of the exercises, and here you really need also patient participation, because people need to do these exercises a few times. I think it's 3 times a day for 12 weeks. And then we're seeing if we can improve the upper airway muscle tone and reduce their sleep apnea severity by this. Preliminary results show that it is quite effective, at least in some patients, but not all. But we wait for the final results of this study. So the take-home message from this is there's a lot of promise for the future of sleep diagnostics and treatment. We definitely do not have all the answers yet, but I think projects like the Sleep Revolution, which is collecting the tens of thousands of sleep studies and really in-depth phenotype data for patients, both subjective and objective data, is the way forward. And I think the only way to do this is to work interdisciplinary. So we are working with a lot of computer scientists, engineers, sports scientists, psychologists with cognitive expertise, etc., in our group, and in addition, of course, to traditional sleep expertise, and together we can make these changes. We need to standardize and validate, of course, all of the new tools we create and others are creating to see if they are clinically beneficial. And I think this type of model can also be extended to different sleep disorders, sleep health in general, and even other long-term diseases, that to really follow people's health and how it changes. Finally, a picture from our last General Assembly in Ghent, Belgium. And I believe you should know some of the people here, both these wonderful Greek colleagues we have, as well as many key opinion leaders in Europe in the field of sleep that we are lucky to have as a part of this project. So thank you very much.
Thank you, Erna, for a very stimulating talk and very much promising about the future. And indeed, we need more ecologically friendly technology, to assess sleep, and that's also one of our goals here. One of the studies we're doing. Also, I was glad to hear, that we're not going to rely just on the machines. We need, the human factor. I recall when myself came across, this kind of automated sleep scoring in 1990. Mm-hmm. You're hoping a lot, but 30 years after, we're still, as you say, searching.
Yeah, but it is interesting. We have a tendency as humans, also like our students and our people who are doing our trials, we have a tendency to believe the objective data over the subjective data. So even if the objective data is a wearable that is really bad at deciding your sleep and gives you some really non-validated indices, you believe it over your own experience. So it's very important that we look at both and connect it in a way that makes sense.
Sure. I do not know if I'm going to ask the coordinator there or the Congress president. Are there going to be time for questions, or this concludes the presentation by Dr. Arnardόttir?
Hello, I'm Katerina Vlami. Can you hear me? Hello. We are for the public health sector. I was wondering about the different approach to specific groups regarding all these new technology for diagnostics and treatment also. And I wonder about especially for the older persons, because sleep apnea is a very popular in this population. So how can we proceed, or how can we approach this specific group? Thank you.
I think that is an excellent question. And of course, for people who are not used to technology, this can be quite daunting. And I think we will know more about that at the end of this prospective study that goes across the whole of Europe. And we will see which of the people coming to our sleep labs are not able to do this at the moment, and we shouldn't invite them to do this. And it may very well be that there are some people, especially the elderly, that do not trust themselves to do it. But they may also, like I actually asked my dad to do it the other day, and he is over 70. And he was very unhappy with his daughter because he thought I should put all of the stuff on him, but I just gave him the device, and it worked perfectly. He actually has an AHI of like 70, but it worked very well, the device. So I don't think we should decide beforehand that people cannot do it. And we can also invite people to do it with a spouse or with, for example, their child, which then maybe in an age group where it is, it's very easy to help. So, but we will know this, of course, and we are trying to cater, like in the app, for people who are visually impaired, color blindness, and we did test it in a lot of different age groups, including the elderly, but more work can be done there. And at the moment, we are throwing the kitchen sink at people. We're asking people to do very extensive data collections with the wearables, with the app, and with the self-applied devices. And one of the aims when we finish the data collection is to see what is the minimum amount of question that gives us the answers we need and how long we need to collect data for. So we really want to reduce the patient burden this way. And also, of course, for the healthcare people, it's a lot of data. But we don't really know which of the data is the best at the moment. So, but we need to figure that out. Thank you for that question.
Thank you. Any other questions? Erna, I have one question for you.
Dear President of the European Sleep Research Association, thank you for accepting our invitation. Thank you very much. And the question, do you think that the era of manual scoring is near to finish?
That's an excellent question. I think we will have a gradual change, and we will spend less time to score simple diagnosis. We will spend less time to score sleep apnea, periodic leg movements. But at the moment, none of these analyses that I've seen are, for example, you would not trust it for narcolepsy or REM sleep behavior at the moment. So I think we will have, 5 to 10 years phase of this gradually going down, and us maybe finding new indices in our sleep studies. I mean, if you think about the fact that the 30-second epoch is based on what fit well on paper, and the way we do sleep stages is based on observations from the 60s, there could be something much more informative in our studies that we're not looking at the moment. And I think machine learning, unsupervised machine learning, where we have the computer find associations and connections in the data, could be used more in the future as well. I think it will take time, and I don't think we should throw the baby out with the bathwater, as Vittorio Bruno likes to say in Italy. We need to do it in a careful manner, and we have to validate extensively whatever new methods we come up with, so we make sure our patients are not losing out.
Okay, thank you very much, Erna. I think we're almost up to half an hour. I had the question, but we can do it at another time.
Always happy to talk with you. And thank you everyone for listening. It was a pleasure. So have a nice conference.